Power Forward. Thanks everybody for sitting through what I'm sure was an incredibly fascinating commission hearing just now. But welcome back to the really, really fun stuff. To introduce our next panel, I'll turn things over to Christina. Christina, go ahead, please.
Welcome to our second Innovation for the Grid panel today, which includes presentations from Don Wingate from Schneider Electric and John McDonald from GE Grid Solutions. Don's going to get us started.
Okay, thank you very much for the opportunity to address the commission and the staff as well as the public. My name is Don Wingate. I'm with General Electric right over here. Used to be with General Electric. No, but I represent Schneider Electric. We're a very large international global energy management company. We have about 160,000 folks that work with us around the globe. And in the United States, we have about 17,000 people. I'll start off by making a couple of maybe pronouncements about what we think is going on in the world and what we think is going on with innovation for the grid. And I'll start off by saying that we think that electricity is a basic human right. When you look around the world, it's really the foundation of education, it's the foundation of employment, it's the foundation of efficiency. And there's about 1 billion people around the world that have no access at all to electricity. And there's about 2.5 billion people around the world that don't have reliable access to electricity. And you might think that's in different parts of the world, but in the United States, there are still people that don't have access. So what we think we have to do as a company and as a society is we need to make sure that we provide safe, reliable electricity that's affordable to people. It's really exciting to talk to the commissioners because you're talking about innovation, you're talking about technology, and you're talking about what the future holds. And when we look at it, we want to look at some trends that are going on, not only in Ohio, but in the United States and around the world. And one of them is urbanization. When we look at some of the statistics that there's going to be over 2.5 billion people that live in urban centers by 2050. And that's pretty significant. You can see it in Ohio, you can see it around the country. The infrastructure was not built for that. The infrastructure was built when it was more of a rural America. Now people are moving into the cities at great numbers, and it's going to continue to be trending that way. So what are we going to do about that? The second one is digitization, and that was mentioned a couple of times over the last day, where there's many more connected devices in the world. In Ohio, and look at your own selves. How many cell phones do you have? How many devices are connected? That's going to increase astronomically over in the future. And what does that mean to our power needs? And what does that mean with the way we access and use information as a consumer, as well as a commercial industrial customer, as well as a utility? And the third trend is industrialization. And the consumption of energy is going to significantly increase as we move forward over the next few years. You always hear about the demand for electricity from the regulated side. It might be stabilizing or contracting, but the demand for energy across the total landscape is increasing at a phenomenal rate. And so what does that opportunity drive for us? It means that with the electrical use growing probably twice as fast as what it's been in the past, as well as the digitization and these connected devices, it leads us to opportunities to be more efficient with what we do. With decarbonization, how do we, as a society and as an industry, use less of things that are harming our atmosphere, harming our people, harming our industries, as well as decentralization, is how do we look at energy being produced differently than it was in the past? And that relates to jobs, it relates to economic opportunities for people. And again, how do we go away, or how do we transition from a model of centralized control, centralized producing of power, to one of a more decentralized view of the world? When Schneider looks at this, we look at kind of this equation as 3 Ds and an E. And decarbonization is the first pillar of that. And what we're saying is that about over 30% of the new generation that's of electrons is going to be done through either photovoltaics, wind, and storage. And that's significant than it was as little as a few years ago. Digitization, the ability, and we talked about it in the last panel, where there's more connected devices that are directly related to the regulated utility industry, but more importantly related to the consumers that are using these things. They need more power, they need more data, they need to be put in a place where we can capture value from it. And the third pillar of this is really decentralization. And what we're talking about, that statistically over half the people want to become a prosumer. That would be our definition for not only consuming electricity, but selling it. Whether it's people that are putting solar on their rooftops, commercial people that are having microgrids installed. A lot of movement right now in the industry is to how do we take a new business model, a new technology, and in this decentralized method, control things and get benefit out of it. And that E part of the equation is that the energy consumption is growing fast. It's going to increase over the next 25 years. And all of those things need to be considered when we look at regulation, when we look at rate structures, when we look at how consumers use energy and do it in a more effective fashion. So what we think and what I'm seeing in the industry is that this does have a really unprecedented change in the whole power industry. It's disrupting existing business models. Whether it's putting distributed generation onto the grid, whether it's looking at energy efficiency in a new light, whether it's intelligently looking at the markets on how consumers and C&I customers buy electricity and use it, it's creating a transformation. And we think that there's probably going to be winners, there's going to be losers, but technology is really going to drive change in the industry. And maybe I can give you a couple of examples. I have down on the chart a public-private partnerships are emerging. And I know there was questions on the last couple of panels about some examples. So I'll give you one. Montgomery County, Maryland. They're right near Washington, D.C., a very fast-growing county. And they wanted to put in a microgrid. They had their county administration building and their jail. They had two different facilities. And the county administration held all their public safety, police, fire, and because of its proximity to D.C., some national security people were in that building. And they experienced several power outages over the last few years. And when they needed that facility the most is when they didn't have power to run it. Their citizens valued sustainability. They wanted to have more green power available, but they had a couple of business problems. Strange, a county government, they didn't have any money to spend. Their budgets were constrained, and they said, we don't have a lot of capital expenditures, but we want to do something different. They wanted to have a view of what their future power bills were going to be over an extended period of time, because they knew that power costs were increasing in their area, and they wanted to be more efficient with their use. So they wanted reliability, they wanted more efficiency, and they didn't have a lot of money to spend. So as an example, we created these, we had a partnership, or it was sort of this public-private partnership, and we found Schneider Electric designed and is building the microgrids. We're doing the project management, we're providing the equipment, we're partnering with people to provide the solar panels, we're partnering people to provide the rotating equipment for the combined heat and power. And significantly, we partnered with a non-regulated utility, Duke Renewables, and in essence what we did is we gave them 2 microgrids that are going to produce 80% of their power, and there is no upfront capital required for them. And we're doing this we gave them a purchase power agreement over a 25-year period of time where we're fixing their electric bill at only 1 cent a kilowatt hour more than what they were paying. So they had no capital expenditure, they're getting reliable energy, 80% of their power needs are being generated from this this microgrid, and they're pretty happy about it. And so that's an example of a public-private partnership to meet the needs of the community, meet the needs of the grid, and I think that's a pretty good example of something that's unique in the industry right now. So what that leads to is a chart that I wanted to show. And there's sort of four components of this, and what we're seeing in the industry is that people are starting to look behind the meter, not necessarily from the public utility, the regulated utility perspective, but behind the meter, people are looking at this and saying, I want to make sure that what I do is very efficient. I want to have a good cost of my electricity. I want to make sure that I can understand I want to pick my fuel sources. I want to do it in a way that's beneficial to my business or my life where I live. They want to be sustainable. Companies are attaching a value to sustainability. It's not just I want to be green and I think this is a good thing and I'll do it because I feel good about it. They're saying that this is really important to my business and my customers and my consumers value when I do something that's green. And they want to be resilient. That is attaching a new meaning to electricity. It's not just turning on the lights. They can't afford outages. If you're a hospital, for example, you value resiliency an awful lot. If you have a power outage and you're in the middle of an operation, you might have UPS, uninterruptible power supplies to keep things going for a short period of time, but you've got to keep people alive. And in your equation, you would value resiliency really, really importantly. In the supply side, that's nothing new. People are finding ways to look at buying their electricity and buying their power in a very efficient way and make sure their bills are low. And when you look at that in the round, this is about active energy management behind the meter, and people are doing this because technology is changing, technology is available that lets people do it irrespective of what the regulated utility does. And I think that it's kind of this new world of energy that we talk about and hear about in the industry, is that how does the regulated utility either participate in this or catch up to this or figure out a way to do it, because technology is happening at a pace that is going to continue. And I think collectively, what does the commission do about it? What does the regulated utility do about it? And what does the consumer do about it to create a new balance? There's a math equation. I know everybody here did good in math, but when you look at what's going on in the world, we think that energy consumption is going to rise by 50%, so take 1.5. We know we want to do it more efficiently and reduce greenhouse gases, so we want to cut that by half. And so you do that math, and we've got to become 3 times more efficient as an industry in order to be sustainable and take good care, be good stewards of our energy resources as we move forward into this next decade. So we wanted to leave time to have a lot of questions, so I'll stop here and turn it over to John, who's going to give you a perspective from General Electric, and then we'll talk more.
So good afternoon. I'm John McDonald. I'm with GE Grid Solutions. I'm a native of the Chicago area, so I've lived in Atlanta for about a little over 30 years. So I'm one of those northerners that comes to the south and falls in love and then doesn't go back home. But GE Grid Solutions is the combination of Alstom Grid and GE. So a year and a half ago, the largest acquisition in GE's history took place in the 130-year history. And the resulting business is Grid Solutions. So the legacy GE business I was in, we quadrupled in size with the addition of a lot of new technology from Alstom Grid. Okay, so just a little brief background on myself and in terms of looking to the future. So I've been working full-time in what we call grid modernization or smart grid for 43 years, full-time. I specialized in power engineering at Purdue, both bachelor's and master's. And of the 43 years, about half the time is spent with 4 different automation suppliers. So I've built systems of all kinds, tested them, installed them. And also the other half of the time is doing international consulting work for electric utilities. You know, what are their needs, business cases, procurement documents to go out and buy technology, represent the utility with evaluating proposals, managing contracts, and making sure that what the utility needed was what was supplied and it'll work properly. The other part of this is being involved in outside activities. You know, I always say there needs to be a good balance between internal focus and external focus, because we need to know what's happening in the world around us so the decisions we make are better decisions. If we're only internally focused, we may make a decision for organization and something may happen with an industry standard or with, you know, something else, and it may impact maybe equipment we've just bought, and all of a sudden it's obsolete in 6 months, and we didn't anticipate that. Okay, so we need to know what's happening in the world around us, and I've always been very involved with leadership positions in a lot of outside organizations in our industry. So just playing on that, let's look at you know, what's happening in the world around us, and so on the edge of the grid, we're doing more on the edge of the grid today than we've ever done before. Okay, and the driver for this is primarily renewables. Okay, when we put solar panels on a rooftop of a home, we're introducing tremendous volatility on that distribution system with voltage, and so one of the things that we haven't had is we haven't had the observability. Jeff Taft talked about this also, and some other speakers. We need to know what's happening at the edge of the grid. In some cases, we haven't modeled that, okay, in our geographic information system. And just as an example, we have 52,000 distribution substations in the United States, and only 2/3 of those today have any kind of automation installed. Okay, so we have large areas of unobservability. And when we go to put in a distribution management system, you know, or a SCADA system for distribution, we have some very powerful applications that can optimize the operation of the distribution system, but they can only optimize what they know is happening, right? You have to have information coming in from substations and the feeders, right, to optimize it. And so we have large areas of unobservability. But the trend is, as Don talked about, is greater connectivity. So the devices, we're putting more devices out there, and connectivity is growing. Okay, so then the question becomes, and I'll get to this, is what do we do with that information that we now have available? One exciting thing that's just happened in a very short time in the past is we've been used to getting data every 1 or 2 seconds from traditional SCADA systems. And we're limited to how much insight that gives us to the grid, because the grid, some things on the grid like stability happen much more quickly than every 2 seconds. We need more granular data, you know, to know what's happening. And now with what we call PMUs, phasor measurement units, or synchrophasors, that we're adding, we have many samples per second. Many samples. So the question for our industry is, how do we make best use of that information? Okay, because now we have traditional SCADA data and synchrophasor data as inputs, and it gives us much more insight in areas of the grid that we didn't have before, and to be able to predict and forecast what's going to happen. But computing power is accelerating with wind turbines and just a substation controller. In the last 10 years, we have 30 times more processing capability. Okay, so there's many things, much more data, a lot of things we want to do, and the processing power has increased. Let's look at utility operations. So there's 3 times the assets now under control than there was before. And there's also market management systems, what we call MMS. So one of the things that's increasing is, and Don talked about this, is microgrids. Microgrids and what we call DERMS, Distributed Energy Resources Management System. DERMS is a fairly new term, and we're developing systems now that look at distributed energy resources to optimize those, to integrate those into the rest of the grid. Third is the cloud, and several speakers today have talked about the cloud. The you know, it's very ideal for the platform of the future, and in fact, last year at the EMS user group meeting, which is all the vendors of the large SCADA systems for generation transmission, what we call EMS. The consensus was that the EMS platform of the future will probably totally be cloud-based. Okay, so this is something that we need to embrace in terms of future architectures and future platforms. And it's really the emerging platform for the future SCADA system. Okay. So another item is better grid utilization. And we need more sensors. We can take advantage of the phaser measurement units, which gives us more granularity. And a couple things that we're doing with that data is remedial action schemes, looking at different contingencies and looking at trigger points out on the grid. If this trigger point happens, what logic do we need to implement right away to keep the grid stable? Right? We want to isolate any disturbance and prevent it from cascading. Fax dispatch. Fax is flexible AC transmission, and we're using high voltage power electronics now to control the flow of electricity. We can prevent, mitigate congestion on transmission. And one thing that we're looking at now is dynamic ratings, okay, and putting that into effect, because typically with the transmission line and with the grid, we make conservative assumptions on what the capacity of that line is, and if we can put sensors there and actually know the actual ambient conditions, the sag of the line, temperature, wind direction, wind speed, we can actually calculate the more accurately what the capacity of that line is. And typically there's a buffer there which could be 10-20% or more, and we can make better use of the existing infrastructure by knowing more accurately what the exact conditions are. Okay? And then digital tools on the distribution system for better grid utilization, we get into volt-var control. So we're controlling voltage and reactive power. We're reducing the amount of losses on the distribution system and conservation voltage reduction. So the one thing that's inevitable is more renewable energy, okay? And so adding renewables to the grid is, can be done at the transmission level, can be done at the distribution level, or the end-use customer, right? And one of the things that I'll talk about in a little bit at the distribution level is the impact of that. But we need to, how do we balance regulating the grid, regulating the power system so that system frequency, actual frequency equals scheduled frequency, and the interchange, right, the buying and selling of electricity across the boundaries on our tie lines, we want to keep that the same. But with the intermittency of renewables, how do we manage that? Because it's very difficult to forecast, particularly wind. And we heard about energy storage, before lunch. But how do we, the load doesn't change, right? It may grow, but the wind may go away and then come back. So how do we keep the load satisfied through the intermittency of the renewables? And better reliability. One of the things that is a big emphasis right now is asset performance management in terms of reliability. The average age of a transformer today in the United States is over 40 years old. The probability of failure is is higher, and because of an aging infrastructure, and it's a multi-million-dollar asset. We can't afford to replace a lot of those at the same time. But on the other hand, we can invest in monitoring and diagnostic equipment that can monitor the health of that asset on a continuous basis and give us that information so we can extend the life of these assets, okay, for a very small investment compared to the total investment of the asset itself. And reliability, Jeff talked about this earlier, but reliability and redundancy are the two things that we work on in the design of an architecture. And when the grid is stressed is where we see the resilient, what the end result is. What is the resiliency of the grid? How well did it withstand the stress? Okay. So two very, very key points are integration and interoperability. The one thing that we do today is an electric utility, what they want is an integrated solution. An integrated solution is a set of technology components that are integrated together. Some may be in the control center, some may be in the substation, some may be out on the feeders, and they all have to work together, right? It's an integrated solution. When we talk about VOLVAR control, fault location, isolation, service restoration, these are solutions, okay? It's a combination of intelligence and a combination of hardware, right? Hardware and software located around the grid. And the challenge for us is they're not all from the same vendor, right? The utility will have components from different vendors, but they all have to be integrated together and they all have to interoperate, okay? And so that's why we have such an emphasis today on industry standards, okay? Industry standards are very, very important. And in 2007, the Energy Independence and Security Act, Title 13, said what the United States should be doing with respect to smart grid. And it made NIST the overall coordinator of smart grid standards, the National Institute of Standards and Technology. And in 2009, through the ARRA, the American Recovery and Reinvestment Act, stimulus funds then were given to NIST to do this work. So there was a group formed called the Smart Grid Interoperability Panel that I was on the board, and Paul Santalella, who is here, was on the board. And Paul represented all the commissioners in the 50 states and District of Columbia. And I chaired that board for over 5 years, okay? And we were responsible for all the development of coordinating the smart grid standards development in the United States. The daunting task, if you're a utility or a commissioner, is how do you advise your utilities with respect to standards? There's over 100 IEEE standards in smart grid. There's over 100 IEC standards. These are standards development organizations. And we went through these and we said, what are the key foundational standards for grid modernization? And that's what I'm showing on this slide. These 16 standards are the key foundational standards. If you just focus on these, then you have a much better chance, much better guarantee about interoperability and integration. So if I'm developing a product at GE, I say, it's a substation controller. Which of these standards do I need to incorporate in my procurement document? In my design document. If I'm in a utility and I'm buying equipment, which standards affect the equipment that I'm buying? I want to make sure that the vendors I look at have embraced these standards. And there are two types. One is communications, so that the devices can communicate with each other. Second is exchanging information with each other. Communicate and exchange information, okay? So these are very, very critical. But one of the lessons we learned after 18 months of deploying smart grid projects, one of the big lessons we learned was integration and interoperability. We're deploying a solution of, number of components from different vendors. And you say a chain is as strong as its weakest link. Well, an integrated solution is as strong as its least mature technology component. And you find that out right away. And fixing something in the field or upgrading something in the field is much more difficult than it is in the lab or in the factory, okay? So after Superstorm Sandy, a lot of questions came up. How can a utility have a more resilient grid? What are the key factors? And at GE a couple of years ago, we were interested in the pulse of the customer. Okay, so we hired Gallup, a professional polling organization, and we polled thousands of utility customers all over the United States. And we said, how many of you would be willing to pay $10 or more per month on your electric bill if that additional money went towards making the grid more resilient? Okay? And it really surprised us that east of the Mississippi, 41% said that they would be willing to pay that $10 or more per month, and 34% west of the Mississippi. And the reason for the difference there is those customers east of the Mississippi have experienced 3 times the outages of those west, so they're much more sensitive and much more, it's more willing to pay more. So that told us 41%. There's a tremendous consumer interest, or actually stronger than interest, in having a resilient grid, okay, and willing to pay additional money for it if that additional money went towards making a grid more resilient. But one of the things I'm showing here is the 5 key components that we need to invest in: smart meters, the metering communications, which is AMI, automated metering infrastructure, the geographic information system, the outage management system, and the distribution management system. So it's one thing to invest in those 5 components and have them upgraded with functionality, but what's really critical is the integration of these components together. And the consensus in the industry today is when a utility buys a DMS, a distribution management system, or what we now call an ADMS, Advanced Distribution Management System, 70 or 30% of the cost of the project is the system, the DMS from the vendor, and 70% is the integration of that DMS with all the other systems and devices in the enterprise. And some examples are, as our speakers before lunch talked about, we can take from a smart meter, I can take voltage from the ends of certain feeders and bring it into the network model in that system, which I need for voltage and reactive power control. And the last gasp communication from a smart meter when there's an outage is tremendous information for me for my outage management system. So, integration is key, and at the customer level, we find that we can take social media, use social media, and empower customers to communicate through social media, send tweets, right, to the utility. And I can put the Twitter handle of the customer in the customer record. So when you send a tweet, I can look at the customer handle and parse that information, and I know the property address. So how can we empower customers to send us information about outages, maybe take photographs of a tree that's fallen on a power line? Because there may be trees across the road that prevent a truck from a utility getting out to that spot to see it for a couple days or longer. Or if customers can be empowered, to send us as much information as possible. And in the same survey we did a couple of years ago, we asked customers, what's your most preferred way to interact with your utility? And 70% said through social media, because that's what we do more on a day-to-day basis. So one thing with renewables, I said we can couple renewables in at the transmission level, distribution level, or at the end-use customer. This is an example of what can happen at the end-use customer level. So in San Diego, on one distribution feeder, 35% of the homes on one feeder all had rooftop solar panels. So 35% of all the homes on one feeder. And these were houses along the Pacific Ocean, so there's a marine layer of fog that was over these homes in the morning, and as it burned off, what happened was all of these homes would begin generating at the same time, and the voltage would spike on the feeder and then oscillate, okay? So what happened was the load tap changer in the substation, its job is, no matter what the fluctuation of the primary voltage is You want to keep the secondary voltage constant. And it's a mechanical control device of 33 different positions, like a rheostat, and 16 up, 16 down, and 1 in the middle. And this tap changer, before any homes installed rooftop solar panels, operated about 5 times per day with a normal fluctuation of voltage. Now with high penetration, 35%, this tap changer is operating 90 to 100 times per day. Its lifetime, expected lifetime, went from over 35 years to less than 5 years. Okay? So as we think about the future grid, with renewables, high penetration of renewables, the volatility is going to be much greater. Okay? And mechanical means of control that we've been using for many years, we have to rethink future control. And from a research point of view, and I know later on we're going to hear from researchers, when we look at universities, we say this opens up some new applications in power electronics. Let's move from mechanical means of control to power electronic based control. And I wrote this article. I give 3 examples here. One is online tap changers that are power electronic based. 2 is a new family of devices that we're now putting on a low voltage network called low voltage network dynamic grid edge controllers. So for the first time, you know, we're putting control devices, set point controllers on the low voltage network to look at voltage and reactive power. And third is more functionality from our traditional inverters, what we call a smart inverter. So at universities and in the industry, we're saying we need to get the power electronic researchers, you know, working more closely with the power system analysis researchers, because there are new applications of power electronics in the grid. Okay? One of the biggest things today is IT-OT convergence, the convergence of the information technology side of the organization to the operations side. And Jeff talked about the Chinese engineer, with the Chinese that said, you know, what we do is what State Grid tells us to do. Early on in smart grid, we were very interested in the United States about what the plans of the Chinese for smart grid. And it was the most profound response that really applies for all of us, and particularly for Power Forward and the United States. So the Chinese, so before we think about smart grid, we need to make sure we have a strong grid. Okay? Very profound. And before we start thinking about a lot of new things and adding those to our existing grid, let's make sure our foundation is sound. We don't want to build a house on top of a concrete foundation with cracks in it. And by strong grid, we really think of 2 things. One, and this was mentioned earlier, the communications infrastructure. Right? Communications enables us to automate. Without communications, we wouldn't be able to automate. So it's really the enabling technology that allows us to automate. So we have to look at the communications infrastructure from 3 points of view. Each application that we want to add is going to have response requirements in seconds. It's going to have bandwidth requirements in bits per second. And it's going to have latency in seconds that it can tolerate or delay. And the underlying communications infrastructure, no matter what application we have, needs to support a wide variability in those three metrics. Okay? So, and the second one is the IT infrastructure, which is what I want to talk about here. If we don't have IT and OT converged, we'll have a disconnect in the enterprise, and we have very valuable information on the operations side. We want to get over to the corporate network so other business groups within the utility can have access to it, and there'll be a disconnect in the enterprise. So on the left side, I'm showing groups within the utility that have their own systems, their own devices, and their own existing repositories, databases, and pretty much, you know, group to group, they have their own needs, they satisfy those needs, but there's not the emphasis to break down the silos between the groups and to work holistically and enterprise-wide. On the right side, when we converge IT and OT, we have a federated data mart, which is our system that pulls it all together, and we basically have data sharing and mapping of all the users out there, both the operators in the control center in business groups like power quality, asset management, maintenance, and they have access to the information that they need. This is such a critical topic that I gave a webinar to NARUC last year, and it's on the NARUC website, a link to a 1-hour webinar that I did with an engineer from PG&E that talked about what they're doing in IT/OT convergence, okay? So this is a very important topic industry-wide. All right, so I want to sum up. Observability is important, making sure we have enough information. A strong grid before a smart grid. I want to summarize and say success in grid modernization to me is like a three-legged stool, and all three legs are extremely important. If one's missing, we'll fall over when we sit down. One is technology, which we all love, and a lot of times we stop at that point. Second is industry standards, and third is policy, okay? Those three are important. I could have the best technology in the world. Policy incentivizes the customer to buy it, but if it's not standards-based, I put it out in the field, it's not going to interoperate successfully. On the other hand, I could have the best technology, it's standards-based, but if policy doesn't incentivize the customer to buy it, no matter how good it is, I may never be successful, okay? So that, a quick overview of some key things, and look forward to discussion with questions. Thank you.
Well, gentlemen, thank you very much. And as with all of our speakers, everyone that has come in is so incredibly knowledgeable, qualified, etc. And so you gentlemen certainly fit that bill. So thanks to the both of you for spending the time to come in and speak with us. Don, so question for you about the concept of decentralization. And I'm curious about whether decentralization is occurring because the technology has evolved to the point where it is a natural course, or if it's consumer sentiment based, or is it a convergence of things that's pushing the concept of decentralization? And for us as regulators who are a little more used to a centralized world, just some thoughts surrounding something that we should be looking at as it pertains to this concept of decentralization.
Yeah, that's a really good question. Decentralization, I think, has a couple of business drivers. One of them is the cost of technology is significantly less today than it was years ago. Gentleman I work with was a nuclear engineer on a submarine 20 years ago. It was really a microgrid. It could last under the sea for 9, 12 months at a time, but it costs like $7 billion to drive this thing around the ocean. Now you can put the right technology in place that can do the job in a decentralized fashion, significantly less than what it was even as little as 2 years ago. Cost of storage has gone down, the cost of solar has gone down, the capability of controllers to do it, and it's really offered the C&I customers mostly a choice, where before their only choice was to buy things from their regulated utility in an economic fashion. Now they don't have to do it that way. And to me, that's put the whole utility model, the regulated utility model, has been significantly disrupted. And consumers are doing things differently because they have choices now, if that makes sense to you.
It does. And so then the corollary is from a regulator's perspective. Obviously, part of what we're trying to do here is prepare for this world. From Schneider Electric's perspective, lessons learned from dealing with policymakers associated with that?
Yeah, if you talk to some of the regulated utilities, they'll say that they're probably 4 to 5 years behind in technology, and sometimes if you talk to commissioners in different states, they'll say that they're 5 years behind the utility.
Yeah.
I'll give you an example. Up in Massachusetts, we have our North American headquarters, and we just installed a microgrid up there. And so we're able to island from the grid. we put the solar parking structures in our parking lot. We put solar on the roof. We have battery storage. We have combined heat and power, and we conduct research there. And it's a laboratory for us. So we cannot, if we run tests, it might take 6-7 months to do some equipment testing. If we have an outage, we have to start over again. So it's very, very costly for us. So again, we partnered with an investor. We got, we stabilized our bills. We have better resiliency. And the challenge was with the regulatory framework, the loser in that battle, Schneider Electric gained from it, our investment partner gained from it, but Northeast Utilities lost load, right? So we're buying less electrons from them than we ever did before. And so who's going to pay for that? I mean, so now they have to spread their costs over a smaller pool. And so we met with the regulator, they visited again, and they said, well, we got to do something about this. We've got to figure out a regulatory framework that would help solve the problem. I don't know what the problem is. I just know that it is a challenge, that the regulated utilities business model is being disrupted. People are leaving. They're going into these distributed resources, and they're really not allowed to participate in the marketplace. Because it really, they're incented to do something different than they are. So they can't go invest that's going to benefit one customer. They have to invest in things that are generate many customers.
Very good.
So that's a
No, thank you.
it's a challenge you face.
Very, very
We
helpful.
face.
John, the NIST requirements with respect to smart grid, the NIST requirements are permissive requirements for those who deploy. Can you elaborate on that, please?
There's not, these requirements are not mandatory requirements, so they're voluntary requirements. I would say they're more market-based. From a market point of view, we know you learn very quickly, like I said, if you don't embrace these standards, right, with technology today, things just aren't going to work. You learn that real quickly. So these are market-driven. For instance, if when an electric utility puts a procurement specification together, they'll talk about which standards, which requirements the proposers need to talk about with respect to their products and their technology. And likewise, from a vendor point of view, when we develop new product, we know what standards we need to incorporate. The real trick, though, is keeping a handle on what new standards are being developed and how will those impact the industry, both from the point of view of the vendors and developing product, but from the point of view of electric utilities purchasing technology.
Okay, and how have you seen, so I'm sure my staff knows a lot more about it, Christina's nodding at me, knows a lot more about this than I do, but how have you seen, or have you seen regulatory commissions, state PUCs take these NIST requirements and mandate them of their utilities who are deploying?
I have no personal experience myself of seeing any situation where things were mandated at all. No.
Okay.
It's, I think, for us, I think with NIST and the Smart Grid Interoperability Panel, really our main mission was to more educate, to make sure that all the commissioners, to make sure the utilities, the vendors, all knew these standards, how they would be used, which ones would be used for which situations, whether it's communications or whether it's information exchange, and make sure that they were used. Okay, but not mandated.
Got it. Very good. Commissioner?
John, piggybacking on what the chairman asked, so do you find most vendors or utilities voluntarily then follow the standards? Do you have any evidence of that or not?
No, that's a great question, and truly, because it's market-based, if you're a vendor, you're not going to be successful for very long if you don't embrace these. And I'll give you some examples. When I was a consultant representing a utility and I would write a procurement spec for utility, there's two things that I would require. One would be these standards, many of these standards have user groups that govern the standard. And these user groups have, in many cases, have approved third-party companies to do independent testing. So if I'm a utility, I'm buying a product, I want to see proof, a certificate from the vendor in their proposal that the product or products that I'm buying have been tested by an independent company, and that's compliance to the standard. But compliance doesn't guarantee interoperability. The second step is these user groups also hold what we call plug fests, where the vendors bring their products to the same location, hook their products on networks to talk to each other, and you truly test the compatibility of talking to each other, and you tweak the code until at the end you truly have interoperability. So to me, and we talked about this earlier today, the bottom line is how can we protect the investment? You know, we could wait, technology changes so quickly, we could wait forever to buy something because every week something new comes out that's bigger and better and less cost. At some point you want to pull the trigger and buy. At that point, how do you best protect your investment? What questions do you ask? And so we look at compliance with respect to standards, and we look at plug fests and interoperability. And that's the best insurance today that you can have with asking the right questions and getting the right documentation.
So future-proofing, as they say, right?
As best as you
Yes.
can. Yeah.
Don, question for you. I read about, I believe it's a pilot that was done in Brooklyn, New York. Is that correct? Could you talk a little bit more about that?
I think, which,
The one, I think that instead of adding substations or additional generation in the area because of the congestion, some really creative things were done in lieu of that to alleviate the need for growing more power and utilizing more space.
a lot of that goes to what we might call non-transmission alternatives. And again, it circles into a microgrid concept where instead of, extending a line, putting in a new substation, new generation, you can create a microgrid for a particular geographic area that instead of having to invest a lot of money in transmission lines or a lot of money in generation, put a smaller, put a geofence around and say this is going to work. It increases resiliency on the grid. It uses more renewable energy. And then it's really helps both the utility and the community that it serves by making it a little more effective. And we're finding these non-transmission alternatives cropping up. Connecticut has a grant program that the DEP part of it, they're issuing grants to let utilities, mostly the munis and co-ops, develop these to save money and provide a different view of it. There's some in New York, and most of the time it's geared on regulatory support to explore new technologies.
That's what I was going to ask you. Was it initiated by the community, the utility, the commission there?
It was in the areas I mentioned, both in New York and Connecticut. It's sort of sponsored by the commission.
Okay. All right. Thank you.
Great. Mr. Johnson.
Yes, Mr. Chairman. In talking about the current grid, and you talked about the current grid a little bit, and then we were given this, before we have a smart grid, we ought to have a strong grid, and I wondered if, when I flip the switch, the lights come on, and I marvel at this grid that we have now, and but I realize that certain parts of it are aged, and I mean, first of all, do you both agree that that you have a strong grid before you have a smart grid, or are we in the middle of this kind of revolution or revolutionary changes? Anyway, could both of you kind of speak to speak to our grid.
Maybe I could start and then John can debate it. Yeah, I think we're at the cusp of technology change. One school of thought is that you invest and get the grid much stronger, because it's kind of running at 100% capacity right now. And we know usage is going to grow, so it's going to break, right? So something's going to break. And so some school of thought is, let's make it stronger, let's make it better, let's have it controlled the way it is. And that will help solve the problem. Then you start modernizing it. The other school of thought is that maybe you don't need as much of maybe you don't need the grid in the traditional sense. If you had, if everybody's house was a little microgrid, and you could have a whole different scenario. The people that would own and administrate the grid could be very different. I think, Commissioner, you asked an interesting question. You said, who should own the grid? And I was sitting in the audience and I said, well, who should own the internet? Does it have to be the utility, the regulated? I don't know. I don't know if it has to be anymore. And I think, collectively, the society has to sort of figure out which way do you want to go and what's the most effective. And my message is that you can't stop technology, and technology is changing so fast and furious. And with renewable energy and distributed resources, the whole business model is just under attack. And it's going to cause havoc, and we have to figure out a way to make it not cause as much, or push it in the right direction. I don't know if that answers your question. Just something to think about.
Yeah, Don's right. I mean, technology is continuing to change, and it's changing very quickly. So there's things that are inevitable. I would say with the advent of smart grid, the biggest impact and the most focus has been on the distribution part of the grid, more so than anything else. And Jeff alluded to some of this morning. Was think about this. We designed the distribution grid for electricity flowing in one direction from source to load. Its architecture is predominant, in many cases, radial, which means the feeder goes from the substation to the last customer, and it's very simple. And so, Chairman Hockey, you asked about centralized and decentralized. I used to ask control center supervisors about moving to more of a distributed model, and this is 15 years ago. They'd say, no control action will take place downstream of my control center without my approval. That was the thinking back then. Things are different today. The distribution system is much more complex. When we add renewable generation on the distribution system, we have electricity now flowing in two directions. We have protection settings that aren't correct anymore because we have a load side contribution to the fault in addition to the source side. That load side contribution to the fault is varying because sun and wind aren't constant, they're intermittent, right? We have much more complexity, and it's only going to grow. So and technology is inevitable to change. So we have to embrace this and say, how can we continue the reliability, resiliency, the factors, the illities talked about this morning with changing technology and just the changing, we want to keep the grid strong, right? And that's why the pace is fast, and we're adding a lot of new things. And that's even more emphasis to have a strong grid. Communications enables us to automate. The IT infrastructure enables us to interoperate, to exchange information across the enterprise. So, I mean, it's mandatory. We have no choice. We have to have a strong grid, and then we can support the new things. And we're going to be adding new things, and we're going to a distributed architecture. And the ultimate architecture today is not centralized, but it's a hybrid of a combination of centralized and distributed, and it has to be that way.
Yeah, and I think just to comment on this, I think the concept is I think you're both espousing concepts that I think run into each other. So we have to have a strong grid before we have a smart grid. At the same time, technology is evolving and we can't stop it. So an example of this, so NERC is presently looking at how to deal with reliability issues associated with the proliferation of distributed resources. And so this is the states are working with, some states are working with NERC to try and figure that particular piece out, and some staffers and commissioners are working to try and figure that out. So I think your messages are the same, and there's some convergence in the messaging. Commissioner Friedman.
Thank you, gentlemen. Just a couple quick questions. John, I believe you used an expression about a federated data mart in one of your slides. We've talked for 2 days now about the enhancements of information and accessibility and transparency. Who do you envision housing that federated data warehouse?
It would be on the corporate network of the utility, and it would be managed by the IT group in the utility. And there's certain requirements of that data mart where it needs to support different types of data that we have. We call operational and non-operational data. And basically what it has to do is, you don't want it to be within the firewalls of operations. You want to take it out of the secure areas. But you want to get the data from the secure areas across the firewalls into that data mart and look at, basically it's a mapping of all the business groups in the utility, the operators in the control center, and I've identified like 25 to 30 different groups in the utility with all the data sources that there are, and identifying all the data sources, whether it's devices or systems or existing repositories, which of those data points have value to one or more groups, and map that together in the data mart. So there's systems available today, technology available today that has the functionality we need, and it's really the core, the nerve center of what we call IT/OT convergence.
Okay, thank you.
Yeah.
Dawn, we've talked about technology and it's kind of driving a sense of a need for change. You exemplified a great partnership, public-private partnership in Maryland. What are the major impediments that you see in terms of proliferating, more and more numerous examples of public-private partnerships?
There's several. One of them is awareness, right? People don't, it's not always uppermost on their mind. Their utility bill is many times a nuisance, right? And so knowing that you can do something different is really important, and I think that will start to come. I'll give you a couple examples. Like virtually every military base in the United States has a stated goal to be grid independent. It's not necessarily to save money, it's to be able to fulfill their mission, right? So that if there's a terrorist attack, national emergency, they do not want to be tied to the grid. They want to have their own capability. So they are, we're doing several of them right now. They are going to remove themselves from the grid. Whether it's going to take 1 year or 10 years, they're just going to do it. That's going to have a significant decrease in the load on the regulated utilities. So people are going to see that and they're going to say, oh, maybe that's something that I could do. So awareness, other examples, but also the rules for net metering. When we put our distributed resources in our headquarters in Boston, we had to constrict the size of the microgrid because we could only put in a 0.5 megawatt microgrid because that was the rule, with the commit, that was it. Massachusetts was near its max. We were able to get a half. We would have put one that was 4 times as big if we could have. But the economics didn't work for us. We put in what we could that made the most sense. So I think there's got to be some awareness on a regulatory perspective to allow people to take advantage of technology. And then there's got to be more examples out there and make it easier.
Was
But I
that-
think the table's been set, though. I mean, when you know, people are putting in, consumers, they're putting in rooftop solar. They don't know that if the grid goes down, that their lights will go out. 90% of the rooftop solar will not operate with a disconnected grid. But people that have rooftop solar could add a battery, and then add an inverter, and add a controller, and all of a sudden they can become more energy independent. So I think there's a wave of things that's going to happen over the next several years that is just going to happen. And, you know, the regulations can either help that or slow it down, but it's going to likely happen.
Thank you. Appreciate it.
Commissioner Conway.
Oh, thank you, Chairman. John, I have a question which is actually, I think, pretty closely aligned to Commissioner Johnson's question. It's pretty basic, which is the comment or the principle, have a strong grid before you have a smart grid, which sounds like it makes a lot of sense. The question is, that I had, and maybe Commissioner Johnson also had, is, well, do you think our grid is strong now? Are we ready to move on to a smart grid, or is there something that we need to do to beef up the existing grid, or to consider doing, in order to be in a position to have a smart grid? Are we behind the eight ball to begin with right now, or are we doing okay, I think? Can we move forward?
Yeah, I mean, it's hard to give a general answer on that, but I would say one of the biggest helps in that regard to move us is in the last, 8 or 9 years, was the $4.5 billion of stimulus funds, that were appropriated, and the number of utilities that use that money to do just what we were talking about. First, strengthen the grid, and second, add new applications, that could provide new value streams, new benefits for them. So we're much better off today, than we were 8, 9 years ago. I think, as we said, technology changes so quickly that the demands of new applications and new technology we want to put out there continue to grow. So we say grid modernization or smart grid is a journey. It's not a destination, So you have to me, you need to continue to look at your communications infrastructure, continue to upgrade certain parts of it that may be older, maybe not have the functionality that you need. And to me, I think one of the biggest needs today with respect to strong grid is not so much the communications, because when you add new technology, you know right away if the communications can support it or not. It's the IT OT convergence and that what I talked about, that aspect of the smart grid, and that's why NARUC wanted a webinar on that subject just last year. For all the commissioners and staffers across NARUC, because that to me is the key, probably the key area of need in general with respect to strong grid.
Okay.
Yeah.
Thank you.
Yeah, John, just so you know, so here in Ohio, and I just want to make sure, I like the concept and it's simple to understand, but I don't want to get too hung up on we have to have a strong grid before we have a smart grid. So I don't think that anybody at the commission will tell you that we are going to forego our basic mission of ensuring the delivery of safe, adequate, and reliable power. And so we obviously have our statutory mandate to do that, and the utilities not only have their distribution rate case opportunities, but also through other forms of rate cases have developed riders to allow for accelerated recovery to keep the grid strong through distribution investments. And so I just, for your edification here in the state, I would say my hope is, because we approve these expenditures, that the state of the grid is strong. Okay, staff. Christina, go ahead.
This question is for Don. I know you mentioned one of the main challenges with the public-private partnership, but I think just more broadly with distributed energy resources is kind of that loss of load issue. In Maryland, following, the successful implementation of this project, did the Maryland PUC, PSC look at what they can do? Was there any formal action taken, I guess? Because I know there was some microgrids that were filed in applications before the commission that were not approved because of certain issues. And I'm just curious if they're doing anything to assess what they can do to kind of address some of those challenges.
I believe that they're sort of waiting and seeing how it goes a little bit. I know that the county has sort of aggressive plans to put other buildings they want to add more microgrids. And I think the utility commission there they're seeking advice. They want to figure out how to do it right. But we're sensing that they're very supportive of it, but they haven't changed any rules right now.
Sorry, go ahead, Patrick.
So, Don, one of the question or comments you said is, and I believe this is kind of a future state that could be, is to every house being a microgrid. And I've read a lot of articles and seen a lot of people that are saying this. And the one thing I've always struggled with and never been able to really grasp is how do we do that for low income? The internet, you can always go to a library, and I'm assuming there's houses without, as odd as it may seem to many people in here, that don't have the internet. We can't have that with electric. So that's the one piece that I've always struggled with, that grand vision. And I'm just curious if you have any thoughts on that.
Yeah. I guess I wouldn't, in my lifetime, I don't think every house will become a microgrid, But I think there's some examples. There's a microgrid that was put in place in South Carolina. And it was a pilot for the utility in the area. And what they did is that they went to their regulator and said, here's what we want to test this concept out. And so they put in a microgrid, and it covered a police station, a fire station, a convenience store, and a low-income housing apartment complex. And what they said is we're going to make this area more resilient. They were able to get that funding approved, and they put that in. So it wasn't taking it down to the individual apartment level, but it was taking it down to the community level. And I think maybe one step is that you could start having these distributed resource clusters be put in place and incentivized better so that you can serve all classes of people and all classes of customers. Because I think that's a really important point. You can't leave people behind. I don't think that's the charter of a commission. That's not the charter of what the utilities want. You have to be able to figure out a way to serve all the people.
Thank you.
Others? Nope. Don, John, thank you very much. Really appreciate you coming.
Thank you.
Okay. Are our two professors in the room that are going to close our day out today? Maybe, maybe not. Okay, so we have a longer break. We will reconvene at 3 o'clock. So we've got a little break. Thank you.